Today we will see melting and pouring from manufacturing technology. Pouring, the molten metal is poured in or injected into the mold cavity. Many difficulties are encountered during the pouring, and this can be overcome by using the uh, water using the appropriate gating systems, which ensures the distributions of molten metal in the mold cavity at proper rate without much temperature drop, without much turbulence, and with minimum entrapping of gases and slags. During pouring, two main considerations are pouring temperatures. Selection of pouring temperature is marked by factors such hot curing and the lower limit by ability of molten metal to flow the thin sections and widens of the skills and ladles. It is also influences of the metal graphic structures, particularly the grain size and structures. Fluidity of the molten metal, which affects its ability to flow and fill the mold cavity, depends on the casting materials and the mold configurations in the general lower viscosity, the higher is the fluidity. Therefore, at higher pouring temperatures, the fluidity will increase since the viscosity decreases. If pouring is carried out at the temperatures of higher than the required, increase the fluidity may cause the molten metal to give and get into the small videos between the sand particles and cause the surface defects. However, low pouring temperatures, fluidity of molten metal may not be adequate to fill the entire mold cavity. With the pouring temperatures, another problem is associated with the amount trapped gases in the liquid metal. Since the solubility of gas increases significantly with an increase in temperature, therefore, in order to minimize the defects in castings due to trapped gases, the pouring temperature extends. The superheat should be kept low in ferrous materials. The removal of gases like hydrogen and nitrogen is accomplished by passing the CO gases through the molten metal. For non-ferrous metals, chlorine, helium, and argon gases are invariably used. As fluidity consideration and minimizations of gas solubility are two requirements of optimum temperatures. However, decided on the basis of fluidity requirements, the temperature should be such that the molten metal fills all the sections of the mold before beginning to freeze. At the same time, there should be the penetration voids between the particles in the mold. Pouring time and pouring rate. Pouring time taken in pouring. The molten metal is poured for castings. It plays an important role as is time, adjusted according to the requirement of good castings. Pouring rate in general depends upon the casting material and the casting configuration. If the pouring rate of the liquid metal is low, then the time taken to the fill mold cavity may be efficiently long. Molten metal may be begin. Solidity of the mold is completely filled. This could be avoided by using the high pouring temperature, but gas solubility and fluidity may cause the problems. Alternatively, higher pouring rate may be used, but this may be cause the erosion of mold surface and turbulence. The optimum pouring rate is therefore compromised. The taken ensure the entire mold cavity is filled before the start solidification without causing erosion of mold surfaces and due turbulence. Gating systems. The design requirement of gating systems. Any gating should be aimed to provide the defect of free castings. This can be achieved by making the provisions for certain requirements while designing the gating systems. The metal should be followed smoothly into the mold without any turbulence. The mold should be completely filled in the smallest time possible without having the raise of the metal temperatures, nor use the metal heads. The gating system is ensured that enough metal reaches the mold cavity. The metal cavity is into the mold cavity should be properly controlled in such a way that aspiration of the atmospheric air is prevented. The metal flow should be maintained in such a way that no gating or mold erosion takes place. Unwanted material such as slags, dross, and the other mold material should not be allowed to enter the mold cavity. Proper thermal gradient be maintained. The casting could be without any shrinkages, cavities of the distortions. The designs of gating economical, easy to implement to improve the factor of the casting solidifications. The basic elements of gating systems are pouring basin, screw base bell, and skim bump and choke, screw, runner, gauge, and riser. Pouring basins. The molten metal from the ladle is poured into the pouring basins from when it moves into the screw and through the runner and other areas. The basin is maintains the constant pouring hid through the vat, cooled black the slag and dirt, which float on the surface of molten metal. Sprue. The vertical passageway through which molten metal flows down from the parting plane is called sprue. It is connected to the mold cavity by gate and series of the gate. Solidified, the metal is occupies the sprue passage after the mold has been poured is known as the sprue casting. The function of the sprue is provided by the entrance wood cavity for molten metal. Sprues may be designed with either positive taper or reverse taper. Sprue based well. At the bottom of the sprue reservoir for molten metal is called sprue well. It serves as the dissipate kinetic energy of the falling stream of molten metal. The molten metal then changes the direction on flows into the runner. The ceramic wire brush filters or sometimes placed on the at the sprue base to filter out the dross and other large intrusions. Splash core is a piece of ceramic backed and sand core inserted in the mold directly beneath of the sprue prevent the erosions of the mold. Sand when the molten metal strikes it at base of the sprue. Runner. It is generally located in the horizontal plane which connects the sprue and integrates the lighting of the metal enters the mold cavity. The runners are normally made of trapezoidal in cross sections. It is general practice for ferrous metal and to cut the runners in the coop of the imitates in the tracks. The main reason for the trap and slag draws which lighter dust strapped in the upper portions of the runners. For effective trapping of the slag is more than the amount of flowing through the immigrants. The runner would always be full and thus the slag trapping would be take place. But when the metal flowing through the engage or more than the flowing through the runners, then the runners would be filled, only the partially slag would enter the mold cavity. Runner extension. The runner is extended a little further encounters and engage. The extension is provided for the trap slag and the molten metal. The metal is initially becomes along with the slag floating on the top surface, ladle, straight gating behind the engage trap of the runner extension. Skin bob. The enlargement of the along the runner of the functions. Trap heavier is lighter impurities, such as dross or eroded sand. It thus prevents these impurities from going into the mold cavity. Gates. Gates are also called as empties, openings through the which molten metal enters the mold cavity, the sheet and cross section of the engate, such it can be readily be broken off of the casting solidification, allow the metal quickly into the mold cavity. Gates depending upon their position of the top coating and bottom type step gate. Top gate. The top gate are usually limited to the small, simple and should be larger castings made in the molds of erosion. Resistance materials. Top gating is not available for the light oxidable materials and aluminum, magnesium because of fear of the equipment of the turbulent pouring. Potting gate. And the name implies the metal enters to the mold. Potting plane. When the part of casting is in the cope and part of the track. For mold cavity in the track, it is the top gate, and for the cavity in the top and the bottom gate. This type of the gating tries to drive the best of both types of gates on top and bottom gates. Of all gates, this also easiest and most economical preparation. This is the most widely used gate in the sand castings. Bottom gate. In the bottom gating, the flows down the bottom of the mold cavity in the track and enters at the bottom of the casting and rises gently in the mold and around the course. In this case, turbulence and mold erosion are least. However, the time taken to fill the mold is more. In bottom gating, the directional solidification difficult to achieve because of the metal continue to lose its heat into the mold cavity. When it reaches the riser, metal becomes much cooler. Step gate. Step gate of the metal enters the cavity through the number of gates, which are arranged in vertical steps. The sizes of gates are normally increased from the top of the bottom and such that the metal enters the mold cavity from the bottom of the gate. Then progressively moves the high gauge, gradual filling of mold without any mold erosion and produces the sound in castings. These kits are used for the heavy and large castings. While designing a casting, it is essential to choose a suitable gate. Considering the casting material, casting shapes and size to produce the sound casting. Gear ratio. It is defined as the ratio of the sprue area, total runner area, total gate area, sprue area, runner area, and gate area. Choke. It is the part of the gating systems which has the smallest cross-sectional area of the performs the following functions. To control the rate of the metal flow, help the lower flow velocity of the runner, hold back the slack of the foreign material, and float the scope and side of the runner to minimize the sand erosion in the runner. Now, according to the locations of the gating systems, pressurized gating systems. In these systems, in-gauge serves as a choke. The system maintains the back pressure and causes the entire gating systems to become the pressurized. In these systems, molten metal enters the mold cavity uniformly. A typical gating ratio in these systems can be 4:3:2. The pressurized systems are generally smaller in the volume of given metal flow rather than the unpressurized ones. This system is adopted for metals like iron, steel, and brass. Unpressurized gating systems. In these systems, sprue as the services of choke. The typical gating ratios in these systems can be 1:2:1, 1:2:4, 1:3:3, 1:4:4. In such systems, careful design is required for ensure them being kept filled during the pouring. Track runners and cope gates are maintained in the full runner, but careful streaming is essential to eliminate the separate effects of constant air preparation. Such systems is adopted for light and audible metals like aluminum, magnesium, but the turbulence is minimized by slowing down the rate of the metal flow. Riser. The riser are reservoirs designed and located to feed the molten metal to the solidifying casting. To compensate the solidification shrinkage, the riser is the hole and cut molded in the cope to permit the molten metal to rise above the highest point of the castings. It provides the visual checks to ensure the filling up molding cavity. The riser should be designed the minimum possible volume while maintaining the solidification time longer than that of the castings. The flow of the liquid metals from the risers to solidifying the casting occurs only during the early part of the solidification process. This means that the volume of the riser should be much more than the shrinkage volume, a value of 3 times shrinkage volume generally considered to be adequate. Recommends of riser. It should be effective in establishing the pronounced temperatures gradients with castings so that the casting will be solidified directionally towards the riser. Its volume must be sufficient to compensate the metal shrinkage within the castings. It must be last part of the casting solidified such that all the shrinkages that are likely to occur should be in riser. It must be cover completely casting sections that requires the feedings. Inside the riser, the fluidity of the metal must be maintained so that the metal can be flow from the penetrate to last concentration cavity. Location of the riser. In order to ensure that the liquid metal from the riser is supplied to the desired locations within the casting, the location of the riser is an important consideration to achieve this. The riser should be located in such a way that the direction of solidification is apparent, since the heaviest sections of casting solidifies the last. The riser should be located to feed in these sections. Heavy sections will now the riser, but the other sections which are not heavy or thick. For small castings, a single riser can be fit to the entire castings, but more than the one risers required for the long castings. The number of the risers or locations depend upon the casting configurations. The risers are generally located at a short distance, since they are ultimately separated from the final casting. The connecting channel between the castings and risers should be large enough to ensure the freeze before the castings. Type of risers: top risers and side risers, open risers. Top risers, it is located on the top of the casting and has advantages of additional pressure, heat and small feeding distance over the side of the riser, which is placed adjacent to the castings. Side risers, it is filled last and contains the artist metal. It receives the molten metal directly from the runner before it enters into the mold cavity and is more effective than the top risers. Open risers. These risers are open the atmosphere at the top surface of the mold. Advantages: can be easily molded. Since it is an open atmosphere, it will not draw the metal from the casting, except the partial vacuum in the riser. Such risers serves as a collector, non-metallic inclusions floating up to the surface. Limitations: their height should be the commensurate with the height of the core, the residues of the yield of the castings. These are holes through the which foreign matter may get into the mold cavity. Blind riser. The riser does not break the top of the cope of the entirely surrounded by molding. Sand is known as the blind riser. The riser often made rounded at the top of the effect of the metal savings, because the hemispherical shape the smallest surface area of the volume ratio. Advantages: can be removed more easily from casting than the open riser. Since the blind riser is surrounded all sides by molding sand, therefore it loses the heat slowly, which helps in better directional solidification of casting. It can be smaller than the compatible open riser, therefore more yield is obtained. Limitations: as the metal is it cools, metal skins may be quickly formed on its walls. This results in vacuum riser, and riser will not be actually draw metal from casting. This may be avoided by the inserting permeable dry sand core and riser cavity, connecting it to the mold and sand layers. Though these layers are fuses, the riser interior and thus the risers operated under the atmospheric pressure. Riser design. If during the casting on no riser is provided, the solidification will start from falls and liquid metal in the center will be surrounded by the solidified shell. Contracting liquid will be produces the voice toward the center of the casting. Further cooling of solid center are the undesirable stresses in the castings. The above problems overcome by the provisions of races as the supply of the molten metal for solidifying the castings. To accomplish these rises must be large enough to remain the liquid after the casting has solidified, must be contain the sufficient metal, and the contraction of losses further. This should be cushioned that the continuous supply through the solidification period. The risers should lose heat and slower rate. Design and solidify the loss as the feed enough the metal and heavy sections of the castings make the shrinkage before during solidifications. For a given size of the risers should be designed with high volume by surface area. These conditions can be met when risers is a spherical in shape, so that its surface area is minimum for a given volume. The cylinder is the next best practical shape, the rectangular sections being very inefficient and must be avoided as far as possible, since the risers are spherical shapes are difficult to mold. Therefore, the cylinders are probably the best shape used for general run castings. The height of the risers should be tall enough so that any pipe is formed may not be penetrate the casting ratio. Height to the diameter usually varies from 1 is to 1, 3 is to 2. The riser is casting relations. The Carney's method. This method is determining the risers based on the experimentally determine the hyperbolic relations, relative freezing, volume casting, and risers. According to the Cairn, the casting is solidifies infinitely rapidly, and the feeder volume would equal to the solidifications shrinkage of casting, and if the feeder and casting solidify the same rate of the feeder should be infinitely large. For determining the riser size, the given casting, the diameter and height of the riser are assumed. Then, knowing the value of EBC values of RF and RV are calculated and plotted the hyperbolic curve. Then the cooling and solidifications. After the mold cavity is fitted on the molten metal, the is allowed for the solidify in the desired shape. The solidification process is decay of the structural features in the materials and controls the properties of castings. The liquid measure is poured into the mold cavity at a temperature much higher than the freezing temperatures, which the pure metal is completely liquid is below the and completely solid, also called the equilibrium metal temperatures. Allow the sufficient time for the liquid metal and to flow the cornice and mold cavity before begins a freeze. Differences between the pouring temperature and freezing temperature is known as the superheated temperatures. Understanding of solidification mechanisms, the rate of the heat losses for the materials to mold, etc. It is necessary to predict how the castings will solidify with avoids casting defects. Such streams are the gas holes and hot tears, etc. We know that the solidification requires energy to produce the crystalline cluster. Some supercooling is required before liquid metal starts to solidifying. This cooling is provided by the mold, which provides the sites around which the crystals can grow initially and voids of the sites around which the crystal grow in the subsequently solidified particles and the metal itself. In the case of the castings, after pouring the molten metal mold, the temperature falls steadily until the freezing commences at a particular point. During the solidification, the temperature is more or less remains constant due to the release of latent heat. In fact, there may be the slight increase in temperature if the supercooling has occurred. The temperatures again starts the falling steadily in the case of the pure metal. In the case of the alloy, commencement of crystallization followed a period of less sleep temperature reduction while metal will passing through the Murphy state. Since an alloy does not have the sharply defined freezing temperature, solidification takes place over the range temperatures, the solid separating out the different temperatures, therefore passes the different compositions. The directions of crystal growth is thus dependent upon the comparison of the gradient with the castings of variations of solids, the temperature of compositions, the thermal gradient within the molds, and the crystal growth in the case of alloys and is dendritic structures. During the cooling, many characters such as crystal structures alloy the composition at the different parts of casing is decided. Unless the proper care is taken during the cooling, defects and link shrinkages, cavity coldness and misrun and hot tear occur. Due to all these reasons, the direction of the crystal growth depends upon the various factors such as the variation of temperatures with compositions, the thermal gradient of the within the mold, thermal gradient within the castings, the cooling patterns of the cooking curves of useful low pouring temperatures, which will cause partially filled cavities. Also, this is used to find pouring the temperature and create the hard casting. In direction solidifications, the aims of producing these sound castings, the solidifications continues progressively from thinnest section of solidifies the first towards the rises should be least solidified. Designing and positions of gating systems of the users properly, increasing the thickness of creations of the sections, casting use of the ponding, use of the exonic materials, placing the sand around the certain portions of casting, use of the chills in molds, chills. Chills or molds in the provider increase the extraction of the capability of the sand mold. Chill provides the sleeper temperature, gradient and directional solidifications as required in casting be obtained. The chills are the metallic objects of higher heat absorbing capability than the sand mold. External chills. Mold cavity adjoining the mold cavity at any required positions. Internal chills. Mold cavity when the external chills cannot be provided. They are used for the either impractical or impossible to rise on thick sections of the castings. However, it can be used along with rises if possible. Chills and rises are placed massive portions produced at the point in production of casting completely free from the construction voids. Chills are metal objects in the form of the rods, wire nails, either cast or made from the rolled stock. Casting. Casting means pouring the metal into the mold. Where the solidification occurs, the metal casting may also defined as the process of production of objects, discrete shapes and sizes by introduction of molten metal into the pre-designed mold cavity created commonly in a compact sand mass with the help of the pattern or in a metallic mold and allowing into this to solidify. Almost every finished metal product has been cast at some stages of its manufacture. For example, all rolled forged steel are initially the form of the cast in course, and even after extensive of outworking, the evidence of casting structure may be still remain in the form of the solids, chemical segregations of the surface defects. The main advantages of the foundry process in flexibility or possibility of making all sorts of the types of the castings for a wide range of the applications. Advantages and disadvantages of the casting process. Cheapest method of fabrications. Object large size is produced easily. The objects having the complex and complicated shapes which cannot be produced in another method of productions. Casting wide range of the properties allowing the elements by proper selection type of the molding casting required for the dimension accuracy in casting can be achieved. Almost all the metals and alloys and plastics can be cast. The number of the castings now can vary from very few several thousands. Disadvantages. The time required for process of making the casting and the quite long the metal castings provides the melting metal and in which the energy is consuming the process. Working conditions in the foundations are quite bad and the heat dust of fume and slag etc. The molten metal casting is still highly labor intensive and compared with the other processes. Preparation of castings. The preparation of the pattern, preparation of molding sand, preparation of mold and core, melting the metal, pouring of metal in the mold, and cooling and solidifications, removing of casting from the mold and fettling. Basic rules of good castings. The following of some are the important basic rules of the uh, for castings in designs. The design of all sections is clearly nearly uniform in thickness as possible. All the parts should be sufficient thickness for the proper running of metal and the mold. All the parts should be sufficient thickness and proper running of the metals in the mold. Avoid the abrupt section changes, making the transition gradual and blending behavior section into the light ones. Minimum number of the sections should be brought together, number of the functions to be staged. Use gentle corners, avoid the sharp angles, cooling surfaces to be always prevented, reduce the bosses and lugs, pads and the other projections. Return of the angles should be wider, openings and casings walls and should be charged ready and curvature of gradual changes. Adjoining sections, please corners and ready, avoid the stress of the concentrations. Drip should be employed only where necessary to increase the strength and reduce the weight of the void wastage. Avoid the intersectings of the ribs by staggering. Since the ribs are provided for the stiffness to reduce the thickness of the rib and should be equal to 80% of the casting thickness and should be a rounded edge of the correctly filtered. Multiplicity of the core should be avoided. Avoid the intersecting ribs by staggering. The casting process, sand casting, shell molding, plaster molding, ceramic molding, vacuum casting, evaporative pattern, investment casting, slash casting, pressure casting, die casting, centrifugal casting, skewers casting, sensorinal casting, continuous castings. Sand castings. This is it is since produce the local hard surface, a core form the shaft opening, screw for running the molten metal into the cavity. Wood of the metal, approximately the shape of the may be removed from either cope or trap. Section molded without disturbing the sand has been packed around the trapper of draft. Few degree must be metal faces of the pattern. Since the casting alloys the decrease of the volume as the solidify cools the room temperatures, it increases to make the pattern of the larger than the financial castings and amount known as the shrinkage allowances. Shrinkage depends upon the such factors as the kind of following and cast design casting, pouring temperatures and size of the castings, making the castings of the U shape. It is necessary to react on the distort of the patterns in order to additional machine allowance of 1.6 km that are machined. Finally, even with the use of the best available motions of the shrinkage, no limit of the shape, almost the metal of the cast, low equipment is cost, economical low volume of productions, low productions rate, extreme complexity possible, low tool cost, and most of the direct route of the pattern of the castings limitations. Product gives a rough surface The dimensional accuracy is difficult, thin projection of not practical, machining is always necessary, shell molding casting. Shell molding casting is the modification of a sand casting relatively shell forms mold cavity is the molten metal is poured. Shell molded casting is capable of producing the semi-precise casting which may not be required subsequent machining. However, the casting can be require the dimensional accuracy of the demands. The mold material consists of the phenolic resins with fine dry silica, presence of alcohol. The pattern is used for the Greek casting. Minimum of the brass accurately machined at the dimensional surface finish. Normally, strips are followed or machine pattern with good surface finish is heated up to about 230 to 260 degrees centigrade. The sand resin fixtures are mixed dumped to allow the brown over its surface. Hot pattern melts the hardness of the resin, since the grind and resin very closely and firmly within 20 to 30 seconds. A layer of sand resin mixture is the sand grains of the clean off. The thickness of the shell is controlled by dwelling line. The weight of the molten metal poured in the shell cavity. The shell pattern is 300 to 300 degrees centigrade, 15 to 60 seconds. Now the pattern is by means of the ejector pins. The mounted on the pattern, the shell is formed constitutes one of the mold and second of the mold also purports similar way to such a way complete shell mold of the cavity which the molten metal can be poured. Sometimes the shell cavity wall is dependent onto the skull molder and the casting produced by this process have a better finish of dimension tolerance than the sand castings. The process of economical large number of similar bud shell items, reasonable sharp corners, small projections of the thin sections are required. Advantages: very smooth surface is generally obtained. The shell cast parts can be produced by with the dimensional tolerance and reduced cleaning of machining cost, gives the rapid production rate, uniform grain structure, minimum finishing operations. Molds can be stored until the required. The complex shapes can be produced with least labor. The process can be automated fairly and easily. Less skilled labor is required. Disadvantages: the resin binder is more expensive than the other binders. The initial cost of the metal patterns and other specialized equipments is high. The dimensional limitations: the limited to some specific metals. Minimum thickness is 4 mm. Application: shell mold is small mechanical parts require the high levels of precision and gear bushings, cylinder heads and connecting rods. Shell molding is widely used for producing the high precision molding cores such as engine blocks and water jackets. Plaster mold castings: in the precision of casting process, the molding is made of the plaster of Paris. In addition, takes place silica of the floor, improve the strength and control the plaster of sheet. These components are mixed with the water and resulting the slurry is poured over the pattern. After the plaster sheets is usually within the 15 minutes, the pattern is removed and mold is dried to remove the moisture. The mold cavity is preheated 120 degrees centigrade for the 6 hours. Next, molten metal is poured for the poured into the mold because the plaster gives a very low permeability. The gas involved during the solidification of metal cannot be escaped. Consequently, the molten metal is poured either the vacuum under the pressure. The plaster mold permeability can be increased substantially by process. In this process, the molds are dehydrated and autoclave of the dehydrated in the air of the 14 hours. The another method of increasing the permeability is to use the foamed plaster which contains the trapped of the air bubbles. The patterns of plaster molding are generally made up of aluminum alloys, thermostatic plastics, brass, zinc alloys. Wood patterns are not suitable for the making the large number of the molds since the plaster molds low thermal conductivity, high dimensional accuracy, smooth surface, low porosity. Mold is easily repairable because of the low thermal conductivity, limited non-ferrous metallic castings, dimensional limitations, time consuming. The molds are not permanent. Destroyed of the castings or removed. Applications: casting silver, gold, aluminum, magnesium, copper alloys, and the bronze metals. The ceramic molding castings. Ceramic mold is a precision casting similar to the plaster mold process, the extension of the refractory mold materials suitable for the high temperature application. Coop and drag investment castings. Slurry is a mixture of grained zircon, aluminum oxide, fused silica, which is mixed by bonding agents and poured over the pattern, which has been placed in the flask. The pattern may be made of the wood or metal. After setting the molds, removed and dried, burned off to remove the volatile matter and blacked the mold or clamped firmly and use the ceramic mold. The show of the process. The ceramic is the piecing of blackened molds and strength. The high temperature resistance is refractory stainless steel. The casting and good dimension accuracy of the surface finish ranges the sizes, dies of metalworking, comb shutters, for machining, molds for making the plastic, rubber components, vacuum castings, the mixture of fixed strand and urethane mold over the metal dies and shoot amine vapor. Then the mold held robot particularly immersed into the molten metal induction furnace. The metal may be installed in the air and the vacuum process. The vacuum is releases the high pressure of the mold above the 2/3 of the atmospheric pressure, drawing the molten metal mold cavities through the gate in the bottom of the mold. The molten metal of the furnace the temperature is 35 degrees centigrade above the liquidous temperature. Consequently, the molten metal begins to solidify the fractions of seconds. After the mold filled withdrawn from the molten metal, the process is alternative in the investment and green sand casting and is particularly suitable for the complex shapes with uniform properties. The carbon and low high alloy stainless steel pots weighing as much 70 kg has been the vacuum cast by this method. CLA pots are easily made up of the high volume, relatively low cost, and CLB pots are easily certain react metals. The process can be automated. The cost and similar to those of the grain sand casting. The operative pattern casting. The process is also known as the lost casting under the trade name full mold process, polyester pattern. from the cavity for the castings. The outwardly pattern casting process carried out follows the raw expandable polystyrenes and bits of containing 5% to 8% and placed on the preheated die, usually made up of aluminum polystyrene. Expand takes strips in the cavity. Additional heat is applied to fuse the bond and beads together. The die is then cooled by the and open. The polystyrene pattern is removed. The computer patterns may be made by bonding the various individual sections of the patterns. Hot melt adhesives. The pattern is then coated with the water base refractorily dried and placed in the flask. The flask is filled with lots of fine and sand which surrounds and supports the pattern. The sand is periodically compacted by the various means. Then, without moving the polystyrene pattern, the molten metal is poured into the mold. This section is immediately vaporized the patterns, then completely replacing the space previously occupied by the polystyrene pattern, and the products were vented for surrounding sand. The typical application of the process: cylinder edge and brake components, manifold and automobiles and crankshaft and machine process. The investment castings. This process is molded the prepared around the expandable pattern. The term of investment refers to the specially covering the apparel, in this case refractory of the molds, surroundings refractory covered by the wax pattern. This process involves the following steps. This pattern is made up of injecting semi-solid and liquid bags of the metal die of the shape patterns. The pattern is coated repeatedly, increase its thickness. The wax patterns requires careful handling because they are not strong enough to withstand the forces involved during the mold making. Once the piece is molded, dried and heated, the temperature is 900 degrees centigrade, 170 degrees centigrade for the 4 hours, depending upon the metal cast, to dry out for the crystallization, and molten metal is then poured into the mold. After the metal is solidified, the mold is broken up to the castings and moved. Number of the patterns can be joined to make the whole tree, increasing the process productivity. Advantages: in average work of the choose the tolerance of the maintained extremely the smooth surfaces are produced. Most of the machining operations, including the heat cutting and gear toothing, forming is eliminated. Acceptable metallic analysis lubricate the details of the can be cast. More than one casting can be made at a time. Undercut the other shapes which would not be allowed without the normal pattern or easily obtained. Advantages: the large size of the objects are impractical for investment casting due to the equipments and size of the limits. The investment molds are well material from which they are made in the angle of the purposes. Therefore, they cannot be reused. They increase the production cost. The process of limitations of location of holes in process is expensive. The applications: the part of the computers and data processing equipment, aerospace industries, and machine boards and accessories. um, costume jewelries, nozzles, buckets, and main blades for gas turbines, radar waves, guides, etc. Slush castings. Slush casting is the processing of the low temperature melting alloys. The principles involves the molten metal, permanent mold, and after the skin has to loosen, the mold turned upside down and slag is removed. Is metal still liquid. The thin walled casting is result the mold type of the time of the operations. The process is suitable for protection of running and generally used for making the mantle and decorative objects. Develop melting, pouring metal of the zinc in the lead alloys. The pressure casting. In this process, molten metals pushed upward the cast pressure and graphite of the metal mold. The pressure is maintained the metal and completely solidified in the mold. Thank you. We'll see you in next video.